but I'm getting ahead of myself. The first time he ever experienced radiant energy was a young boy. While peering out of his bedroom window at a severe lightning storm, his excitement overwhelmed him and he ran straight out into the middle of the storm. Lightning struck a nearby tree, a little shook up, his sneakers muddied, he was not hurt, and it was the first experience with energy that was to mold his thoughts and actions for most of his life. He was plagued with sickness, and throughout his childhood, for lack of adequate nutrition, his dad died when he was just a little over 1 year old. Raised without a father and a mother that had to work, he was forced to raise himself. In spite of his lot in life, he never lost sight of his fascination with energy. His dream was to design and manufacture the finest energy machine to be conceived. He spent every minute that he could at the Manchester City Library. Determined to unlock the secrets of electricity, he read every book on the subject. One day in the library, he found a book called The Sea of Energy in Which the Earth Floats by T.H. Murray. He must have read this book hundreds of times ever since that fateful day. This book has been an inspiration to him. Because of this book, he has carried out several hundreds of experiments from whatever scraps he's managed to find. This dedication to radiant energy has spanned about 15 years. During his early years, he would often walk through the old railway yards to get away from the detractions of everyday life, along with people telling him that he will never reach his star. Today, he walks through conference halls to keep his faith alive. In 1996, he was invited to his first conference to speak about his researches. After this speech, many distractors and people have tried to discredit his lifelong research. In spite of this, he continues to share his research with others. Many people are seeing the importance of his work and are supporting and cheering him on. At his 1997 conference, he met Calvin Ballman, who, by the way, is our following speaker to Mr. Perreault, and has since teamed up with him, whom he considers to be one of the greatest equipment designers that he's ever met. He has come to know him as a best friend. At this year's conferences, Mr. Perreault and Mr. Ballman will attempt to educate us with the many facets of their research, the problems they face, and emphasize the necessity to keep this research out of the hands of those who will use it for destructive purposes. Without any further ado, it gives me great pleasure to introduce to you Mr. Bruce A. Perreault.
Good afternoon, folks. This morning, as I walked through these conference halls, I found something very disturbing on the tables. Somebody had left a packet here for folks to pick up called Assessment of Bruce Perreault's Radiant Energy Research Manual, Volume 201. This was the packet that I gave out in my workshop. Every paragraph has been analyzed and is a great discredit to my work. I'm going to pass these manuals out, this analysis that greatly discredits my work, and it's very discouraging. And I'd like to address every one of these statements in this manual to discredit my work at the September Tesla Symposium. I wasn't going to go to the Tesla Symposium. I was back and forth with the thought if I was going to go or not, and now this, I have to go and address every one of these things that these people have. I don't know who this person is or persons that have done this, but I will address every one of these statements in this at the Tesla conference. They put out, I don't know how many these are, but I'll pass them out among you, and if you could make copies, extra copies, whoever wants one, if you could. Make a copy for you. Okay, thank you. I really hadn't planned for this occurrence here. I'd like to start with I would like to begin with, I have some notarized papers throughout the years that will publicly document some of my research. And one in particular, I didn't know that it went back that far, but it's signed by me December 16, 1988. This particular document isn't notarized, but it's an indicator of my first concept of the capture capacitor without even knowing that, of course I coined the phrase capture capacitor later on. Is it possible for you to get, it's not a transparency? I don't. Can you hold it up in front of the camera so that, Calvin? Okay, could I have an assistant? Anybody? Okay, hold it in front of the camera after I show everybody. This is dated December 16, 1988, signed by me. Most of my notes, that's what I do. Whenever I make a diagram, I date it and sign it, and the documents that are more important or appear more important at the time, I get notarized. And the most important documents I have sent to the patent office and have received disclosure document numbers. You see here, this is a open-end Pyrex tube, copper rod through a stopper on the left, zinc rod, stopper on the right, wire in the middle, AC energy, indicate, showing that this is a basic, the first concept of the capture capacitor. Down here I have another typewritten note here, November 20th, 1992. I have found it advantageous to introduce chlorine gas to the tube. High voltage electrostatic field renders the tube conductive. When the tube becomes conductive, it produces energy. Could you hold that up in front of the camera to get that documented? My next relevant entry, February 1991. It's for a semi-conductive dopant material. It's not my original invention. T.H. Morey invented this phosphor for a very efficient transistor. This isn't even used today, but if used today, the transistor would run much cooler, could be much smaller. It consists of zinc sulfide. Now, this you can read in the Sea of Energy. It's called triboluminescent zinc. Today, this is known as electroluminescent phosphor. And in the 5th edition, 3 dopant materials are left out of the description for patent reasons. T.H. Morey's patent. Zinc sulfide added to present state-of-the-art dopant materials enhances the efficiency of semiconductor materials. Zinc sulfide is usually sensitive to radiant energies, is unusually sensitive. The zinc sulfide additive gives a semiconductor material a unique absorbent quality. Radiations are absorbed throughout the material. Present state-of-the-art semiconductor materials can only obtain energy through energy reflected from the material surface. With zinc sulfide combinations, energy can be absorbed throughout the material. This is dated and notarized February 2nd, 1991. You could hold that in front of the... Okay. Well, I can make these available for inspection after the conference. Next on the list is radiant energy power material. This was fashioned after Morey's lead formula in his electrotherapeutic patent. One of the most sensitive materials is mineral galena. In early experiments, a piece of galena, lead sulfide, was mounted on a brass disc by means of tin solder. Number 30 gauge copper wire called a cat whisker was rested gently on the surface of the mineral. It is sometimes difficult to find sensitive specimens of galena, but it is a matter of record and a proven fact that when a really first-class specimen is obtained, it is practically second to no other detector, not even to state-of-the-art semiconductor materials. Broadcasts have been received with a galena detector and simple equipment comprising a tuning coil, tin foil, and paper condenser, and a single high-resistant telephone or crystal earphone over a distance of 2,000 miles when the transmitting station was only rated at 5 kilowatts. My research indicates galena contains impurities, bismuth, arsenic, antimony, and silver. With this data, I was able to formulate semiconductor materials which are superior to present art materials. The best combinations found are lead 55%, sulfur 30%. The remaining 15% composition depends upon the material type desired. Silver or copper for positive, P-type material. Zinc for negative, N-type material. Now, I could be wrong on zinc being N or P-type material. I'm a self-educated chemist. I don't have any degrees behind me. Radioactive substances can be used in the remaining 15% composition. Material types containing radioactive substances are sandwiched between positive P-type and negative N-type materials. This arrangement transforms radiant energy given off by the radioactive substance into electrical current. And a little bit later on, I think I did in yesterday's workshop. We're not going to have time today, but those of you who attended, I gave an outline of finding a very good specimen of galena in Sweden, and along with the white Swedish stone. This is dated May 1991. Now the notarized, ready to be patented. The abstract devices disclosed include a new novel device and a radiant energy generator formed with metallic cathode and anode disc. The metal discs are evacuated and provided with external electrical connections leading to the cathode and anode electrodes. Sufficient radiant energy applied to the cathode causes it to emit electrons. Electrons are absorbed by the anode. A generator system is also disclosed in which a solid-state high-voltage source supplies the anode. Enhancement of the radiant energy absorption. Electrical energy is obtained from the external electrical connections leading to the anode and cathode. Dated March 2nd, 1992. And these will be open to, if you want copies made, just pay for the copy, you pass them around. They'll be open so that you can see this prior, my prior art. Now I have a radiant energy synthetic radiation, high P dope I called it, dated February 1992. When electroluminescent EL, phosphor, is subjected to a pulsating electric field, electrons within the phosphor are accelerated to somewhat high kinetic energies. These highly kinetic electrons impact one another, including activator electrons, as they move to and fro within the phosphor material. Electron impact excites the activator electrons to higher energy states. These reactions make this material ideal dope for semiconductor materials. The most widely used EL phosphor is manganese activated zinc sulfide. This is because it is 80% more efficient than any of the other EL phosphors. This EL phosphor is a good choice as a dopant impurity. The heat byproduct generated by today's state-of-the-art semiconductor materials represents inefficiency. The key to highly efficient semiconductors is its impurities. When high P dope is used as an impurity, little heat is generated within the semiconductor material. With this semiconductor, fewer components are needed in electronic applications. This material will bring about wonderful changes if implemented. Dated February 1992. Now I have one disclosure number from the Patent Office, 379485, dated April 12, 1996. After 2 years, it's no longer valid. the disclosure document is only good for 2 years after you submit it to the patent office. Dear Commissioner, I am enclosing a disclosure document of an invention in the energy field which is entitled Method of Utilizing a Power Cell for the Generation of Electrical Energy and Device. And it deals with the alpha decay and alpha fission conversion here. There's even a diagram in here. And that can be open to inspection later also. Okay, I have a patent in front of me that I found, well, it was about 2 months before the April conference, and I was surprised to find it because it's the only patent I've ever found that validates what I'm doing. It's a patent on alpha fission, and the documentation in here is extensive. The guy who developed this process obviously had access to many different universities, doctors, science to confirm the disintegrations and that alpha fission is actually occurring. Dated October 9th, 1998, it's patent number 4961880. The abstract reads, accelerated decay of radioactive materials is used for power production. In the method of this invention, an alpha-emitting radioactive material is placed in a region. The region is selected so that when a negative potential is applied to the region, enhanced alpha decay of the radioactive material results. The energy of the alpha decay particles is captured and converted to thermal energy. One difference in my device is that this guy is using a 300,000 volt source that's mechanical. It's a Van de Graaff generator. My source is an all electronic source. We were using in the first alpha star mode, which I'm going to show you in a few minutes here. In that first circuit, I give credit to Robert Ianini, which I did. It's hard to pronounce. I gave credit to him at my last conference in April. And why I mention this is because it is mentioned in the that discredit manual there. If I had invented the television and I had used somebody's other's high voltage circuit to light up that picture tube, would that mean that I didn't invent that television? Well, anyway, we have developed a circuit on our own with an electronic engineer, sending feedback to each other. That first circuit that we used consumed 25 watts. It now consumes only about a half a watt to produce more of a star effect and also to power the multiplier. The output is approximately 10,000 volts at 25 kilohertz. And the multiplier brings that up to over 300,000 volts required to affect the alpha fission. And let me use this patent to... I'm more of an inventor than a mathematician, or I'm not a university person. So this patent is wonderful because it's very precise and really validates what I've been doing. And this guy wasn't the first guy to use alpha fission. T.H. Morey was. So am I a plagiarist because I wasn't the first guy to do it? You know, what we're trying to, Kelvin and I are trying to perfect this technology to get it out in the world. It never made it here. T.H. Morey never made it. I'm going to read you an article, I think it was back in somewhere in the 30s. Several inventors had discovered this process. It's a nuclear reaction that instead of producing thermal energy and deadly neutrons, it puts out this. High electrostatic energy. This energy, the very first person I know who used this principle was Nikola Tesla. Put up a simple antenna, earth ground, used the potential difference between earth and ground, charged up a high voltage capacitor, dumped that charge across a spark gap, through a step-down transformer, stepped down the high voltage. When the high voltage stepped down, the current was raised, and he was able to put that into a load. Very simple. Couldn't get much energy because it took almost a day to charge up that capacitor. But it was the very first step, just like what I'm going to show you today, what I'm calling a thermal electrolytic capacitor. I'm comparing that to what Tesla did with the antenna and ground. All these guys, they developed a small reactor that instead of putting out thermal energy, put out electrostatic energy and was converting it down in this way, more efficiently. And mysteriously, all these devices have disappeared, never made it to the public. This patent disclosure describes applications of the electrostatic voltage excitation process for decontamination of radioactive waste at nuclear power sites and elsewhere. The generation of nuclear power using alpha, beta, and gamma emitting materials as fuel, the generation of fusion power by the use of the deuterium in water as fuel, and the production of precious metals like rhodium and platinum by accelerated alpha decay. Decontamination. I'm not going to go over this whole patent, just very relevant ones. They'll be available for $3 like you get from the patent office. I'm not making any money off these. 58 pages or 58 columns. The principal source of radioactive waste at nuclear power plants where the spent fuel rods are stored underwater. There are about 400 nuclear power plants, probably more since this patent, 1990, in the world, of which 106 are located in the United States. There are definite plans for the construction of 225 more plants worldwide. The spent fuel rods and other radioactive waste produced by this nation's operating fission burner reactors have been accumulating since 1945. The level of radioactive waste in the United States is now estimated to be anywhere from 9,000 to 40,000 metric tons. The worldwide radioactive waste from fission power plants may well be in excess of 100,000 metric tons. And I'm sure that figure has increased in the last 8 years dramatically since they needed the depleted uranium to irradiate the Iranians, is it? Iraqis, yeah, sorry about that, in the war. And our Gulf veterans are dearly suffering for it today. Their children are coming out mutated, and the government takes no responsibility for it. This is why I'm so adamant at this point not to release some final keys, because I do not want to see this type of destruction. I want it stopped. And I'm sure you do. You have to do something about it. You have to wake people up. Americium-241 source was analyzed with X-ray spectrometer at San Jose State University by Dr. Peter Elgert, a radiation chemist. The numerical printout for the excited source was compared with an unexcited source. That will give you a clue as to the fidelity of this patent. Nuclear power by alpha decay in this patent. The generation of electrical energy and the decontamination of nuclear waste are of great social and economical significance. Two fuel sources of interest in the development of alpha, beta, and gamma power are Uranium-238 and Thorium-232. Their decay chains are detailed in tables 1 and 2. The decay of 1 metric ton of U-238 to lead-206 is the energy equivalent of about 3,500,000 barrels of oil. There are large mineral deposits of U-238 in the United States, Canada, Australia, and elsewhere. Naturally occurring thorium-232 is much more plentiful than U-238. In addition, there are approximately 100,000 metric tons of spent fissile material, rich in non-fissile 238, stored worldwide at about 400 nuclear plants. This material waste can be used as fuel. Now, why are we using it for the 1990s nuclear war to kill people, when it should be used to power greenhouses in Alaska to feed the world's hungry? Why? It's insanity. Spent nuclear fission rods and naturally occurring U-238 and U-232 are rich in energy. The energy content of a spent nuclear fission rod is more than 9 times greater than the fission energy of a fresh fuel rod, enriched with 3% U-235. Conventional fission power reactors can be replaced by alpha power reactors. They're not going to do it. They lose their weapons-grade plutonium. Fresh water and salt water are rich in deuteron fusion energy. You can use alpha fission to react the deuterons in water to get energy. Although the natural abundance of deuterium is a very small percentage in water, I can't read this figure. I'm not very good at math. It's 0.015%. The fusion energy content of 1 gallon of water is equivalent to 300 gallons of gasoline. This is with alpha fission. No wonder Hendershot could have a little small device putting out, I don't know how much, but a lot of energy on the tabletop. Morey had a 60-pound unit that put out 50 kilowatts of energy, which is debatable. That's what's put in the book, but you know, the figures, I've talked over the figures with other people, and seems to indicate about 4,000, 6,000 kilowatts. The word fission refers to the act of splitting an atom into approximately equal parts. The most common usage is in connection with fission of U-235 and Polonium-239, which are used in nuclear burner and breeder reactors. In a broad sense, the word fission also applies to the disintegration of the deuteron by gamma ray. The threshold energy required for this process is the binding energy of deuteron, which is 2.23 million electron volts. The excitation to induce fission of 235 and Pu-239 is provided by a thermal neutron. The U-235 fission reaction discovered by Otto Hahn and Fritz Strassmann in 1938 produced barium-krypton with atomic numbers of 56 and 36 respectively. In the past 50 years, more than 30 ways have been found in which U-235 fissions, which is why we're left with so many deadly radioisotopes in a spent fuel rod, deadly toxic. This would not occur with alpha fission. The fission follows its natural decay order, the same decay order that's found in nature. I'm going to put up some graphics here. This is the natural decay path of uranium. Its half-life is approximately 4.4 billion years, in which it decays into radium, which has a half-life of 1,620 years. The next decay product along the chain is radon, which it's half gone in about 4 days. On this chart, it does not show the next decay chain. I got this chart from my radiological department in New Hampshire. The next product is polonium. And the polonium nature is found in very minute quantities, but it has the highest energy content of any radioactive material. It's almost a pure alpha emitter. And if you speed up the decay process of uranium ore, or maybe even a spent fuel rod, the figures in this application, this patent, indicates that this particular inventor had, by his process, sped up the decay rate of uranium to 25 years. Your byproduct is polonium, and now it can be used as a very, very easily harnessed fuel source. However, I'd like to point out that we don't have to use uranium or thorium. There are a number of isotopes in nature found that if somebody bothered to separate and study, we may have several orders of fuel available to us that are natural. Now this is a chart of what happens in a conventional nuclear reactor. You see over there, you see a slow neutron. It's absorbed by U-235. U-235 becomes unstable and fragments into many, many, many different atoms, because they're fragmented everywhere, and you end up with a lot of deadly isotopes that they don't know what to do with. Well, they're taking depleted uranium and making them into radioactive weapons for modern-day warfare. They're coming up with new ideas each day to get in there and kill faster and get out, when the solution is to supply plentiful energy to the world, feed the world, and we could live out our talents, and in no time we could end up in space, and just instead of expanding our greed, expand our minds and our spiritual well-being. These are some of the most promising isotopes that naturally occur in nature that look very promising to me. One of them I didn't mention, I didn't put on this chart, and I didn't think about it until this conference, because it does not undergo decay naturally, is lithium. But in lithium, and without saying too much, if I hit lithium with the right frequency, it will give off enormous amounts of energy by K capture. The innermost electron shell of that lithium will absorb electron, giving off enormous amounts of energy. T.H. Murray, before he died, developed a unit that would do just this. Lithium is not radioactive. A couple of these devices survived and have disappeared because the people suspected of having these devices were raided. One person, who I won't mention, very close to T.H. Murray, he was raided by 13 sheriffs, and they destroyed everything in his home. And very bitter man today. It's very sad. Such a great accomplishment, not doing good in society. And when are we going to evolve? I'll tell you when you wake up enough people and you get the message out. Let's stop the insanity. And we can't do it with weapons. We can't meet murder with murder. Otherwise, we're no better than they are. This is Hendershott's capacitor. What he did is he took apart an electrolytic spray capacitor in one of the plates, and he wrapped it around a coffee can, and he made two of these. He had a buzzer circuit in there, and he was able to, when he pulsated, once there's resistors in there, so that one side started push-pull circuit, but mechanically done with a buzzer. He got the two tank circuit sides to oscillate out of phase with each other. He was able to produce about 500 watts of energy. Now, this particular device will wear out because an electrolytic capacitor, one of the plates absorbs oxygen in its lattice, not only on the surface when it's at lattice. The cold fusion effect that's being seen today is this same phenomena. It's a theory, but it's a theory that I present that could end the cold fusion fiasco and take some of this research money and put it into some real research. With the cold fusion cell, or what they call in cold fusion today, they use platinum and palladium. Platinum absorbs hydrogen gas very nicely. It stores tremendous amounts of volume of hydrogen, and I'll show you today with a cheap tabletop experiment with the oxygen absorbed in the aluminum lattice, which Hendershot was, well, it's my theory that he used it as a fuel. Instead of getting out the way I'm going to show you today, I'm going to release all that energy that's stored in the last aluminum. He got it out slowly and in the form of electrical current. Today they're doing the same thing with platinum, and it takes a couple days. The solution has to be heated up so that all the pores in the platinum is filled up with hydrogen gas. Then they release it, and when they release it, nobody can understand where all this excess energy comes from. I'll tell you where it comes from. It's stored in the same way that it's stored at the manufacturing plant that produces electrolytic capacitors. I can do the same thing with electrolytic capacitor. Where the hydrogen gas at the nail electrode produces hydrogen absorbed in the platinum electrode. Now you take that and reverse it. All of a sudden, instead of hydrogen gas being produced at one of the electrodes, oxygen. And what happens is a violent reaction. All that energy, all that hydrogen rushes to the oxygen being formed on the surface. It suddenly unites. And when it does that, all that kinetic force, when they come together, releases tremendous gas volumes from that reaction. And I'll show it here. I don't know how long the reaction lasted yesterday, 10, 15 minutes. But like I said, you have to heat up the plates first and get the solution heated for it to absorb all that gas. Same way it's done with electrolytic capacitors at the factory. Normally, if you don't heat up the solution, you get little tiny gas bubbles. A lot of people haven't been able to duplicate Stan Meyer's fuel cell because he left out one thing: to replace one of the electrodes with dissimilar metal, and which I believe to be a thermal effect. I'm getting a lot, and you'll see in that discredited paper there that they're saying that what I have is a lemon battery, the Volta effect, I want to show today with these electrolytic capacitors, industry has put the optimum electrolyte in there so that it conducts the ions but does not react with the metal. A Volta cell, Volta discovered the first primary battery, like the first radiant energy, the first thermal, the first observable, small observable effect. He touched a pair of frog legs with two dissimilar metals and made the frog legs jump. That was electrolytic reaction. They went on to do it with salt solutions. But in this case, all I can do for you is present this, and it's up to you to decide if it's a Volta or it's what I say it is. I'll do it with the electrolyte that's in here, aluminum borate, which does not react with the metal plates. I'll take that same electrolytic capacitor, replace one of the aluminum foil with copper, and the storage effect is enormous. I'll charge up an ordinary electrolytic capacitor and discharge it to a small solar cell motor. You can do this at home. It's an old coffee can, heavy-duty aluminum foil, heavy-duty paper towel. You can use Windex, but the Windex, the ammonia in the Windex, although still very less consuming than most liquids to the aluminum, it's still going to have some corrosion because the ammonia will demonstrate the effect. Or you can take apart electrolytic capacitors, do the same thing, and have no corrosion of the plates. It's a thermoelectric capacitor. And the plate size for a normal electrolytic capacitor is rolled up. The surface area is enormous. I can do the same thing with 3 square inches of plate material and have a small motor run for almost 10 minutes as compared to a high-density electrolytic capacitor. And that's what I'm calling the thermoelectrolytic capacitor. Now, if you were to put, now let's get to radiant energy conversion, how it relates to it. In a direct conversion beta cell, if you put 2 dissimilar metals into inert gas and then expose that junction to radiation, ionizing radiation, you'll ionize the inert gas first to overcome the resistiveness of it, to make it a conductive path to the ions. It takes energy to do that, and then you get a small electrical current out. That's direct conversion. But now if you put an electrolytic solution in there that's ionic enough to conduct the ions, and a solution that very minimally reacts to the plates in there, that ionization from the radiation now does not have to waste energy to make that junction conduct between the 2 dissimilar metals. So you now have a higher efficiency beta cell or alpha cell if you use alpha particles. Beta, if you were to use a salt like tritium. And that's where the improvement is. Cells of this type have been around for many, many years. But to my knowledge, they have never used this unique improvement. This is just one facet of radiant energy. There are many spin-offs that I've observed over the years, and you go crazy try to focus on one of them. and I have very limited finance, and I don't have access to university money, which, by the way, they spend billions and billions of dollars down a rat hole every year into the same experiments year after year that fail, but they continue to fund these projects. It's up to you folks out there to change this. That's the inside of an electrolytic capacitor. And this here is a spiral wound aluminum plate separated by a porous separator. The moisture in there is aluminum borate. Most people, they should know that this is not a battery. I can replace one of these plates with copper and get energy out of it, residual energy from ambient radiation that's present everywhere. Not much to power anything. But that spin-off does have an application as a more compact capacitor. I see many different applications that could be used in. Now in this I have a 3-square plate. This is the tab coming off that. And then I have carbon rods as the other side. The separator is a paper towel there. Now this opposite plate could be a coffee can, just about anything dissimilar to the aluminum, far apart in the electrobalance series. There she is. This one's just the coating taken off, the specifications, and inside that is what's here. All I'm doing is charging that. That's connected to a small solar motor. It's going to discharge rather quickly. Now I'll charge up a one that I have a 3-square inch with the carbon rods. Now I can do the same thing with the aluminum foil plate bought from the store. The copper I bought surplus at an electronic surplus store. But this is neater, and I can demonstrate that also. But okay, that's the negative plate that was loaded with oxygen at the factory. Charge that up. Now I'll discharge that to the same motor. Remember, that's compared to this surface area, 3 square inches. Now, what I realized is I'm not getting 3 square surface area because look at all that space in there. It's not getting any surface contact, just the tips here. But if I make this right, I can run it for about 15 minutes on this surface. It's still enormously minute as compared to all that surface area. Yeah, that's the carbon rods with the paper towel separator, and I cut off a little square piece to fit around that with the tab hanging out so I can connect onto it easy. This is Windex. What's that? A thermoelectric capacitor, because I'm using thermally different plates. And aluminum borate that will not attack the plates. It's not a Volta Cell. Volta Cell will eat at the plates. This is a type of electrolytic reaction, but it's not a primary cell. But this could be considered as a primary cell using Windex because the ammonia will eventually slightly attacks the Kelvin, while I'm doing this, could you demonstrate the potato, the lemon, and the pH of the aluminum borate? Now, if I use 2 aluminum plates, it won't do anything. You won't get any kind of gas bubbles. You won't get any reaction. 2 aluminum plates. I want to get a good contact between the 2 plates. If they lift it, I'm going to lose it. Aluminum, copper, thermally different plates. Right. See, as I'm pushing down, there's a lot of spaces in between here, increasing the resistance and stopping the fan. But anyways, you get the idea. Okay, if you want to do the test here.
What we're going to do is take a piece of Hydrion paper.
Hold on, Kevin.
What we're going to do is take a piece of Hydrion paper, which is a type of litmus paper, and then we touch something that is either a base or an acid, and whatever color we get on this little piece of paper, it will tell you where it is, whether it's an acid or a base. It's not perfectly accurate. The best way would be to have a pH meter. We don't have that here today. But first of all, I'll put it on the lemon. The closest I can see the lemon shows between probably 3 and 4, which is acidic. The potato shows approximately 6, so it's slightly acidic.
What was the last thing you just did? What was the last thing you just did?
The last thing was a potato.
Potato?
You've heard of lemon batteries, you've heard of potato batteries. Don't touch the aluminum.
That's the aluminum borate. So you can get lemon on it. Enough of that?
Yes. This shows almost no change in color. Could be between 6 and 7, and 7 would be considered a neutral pH. Is there a chemist here that would agree with that? Thank you.
Okay, thank you, Kelvin. How are we running on time here? Okay. Okay, I'm going to release all the oxygen that's been stored in that, what they're doing similar with cold fusion with hydrogen in the platinum. You getting that?
Spin the glass half 90 degrees and you'll be able to see the
It's just plain water. I just got out of the pitcher. I'm releasing all the oxygen that's stored in one of the plates. The oxygen was put into the one of the plate surface throughout the lattice at the factory. It had to be first heated up with a little bit of hydrochloric acid to push all that oxygen into the lattice. And that's what they're doing with platinum with cold fusion. And now if I were to take 2 aluminum plates and charge it that way and do this, it's all the oxygen's on the surface, it's not getting into the lattice. The solution has to be heated up before it will be absorbed into the aluminum lattice. That's why electrolytic capacitor works. And that's why cold fusion with hydrogen works. We're running out of time. I'd like to show you a more upbeat thing here for another fuel source that the government is something very positive, but I get a feeling like everything else, they're milking billions of dollars rather than pushing the research forward. Could you run that tape? Lights?
While you rock around, why don't you summarize while the tape's coming up?
Summarize what?
All right, you're pushing the oxygen out, and that's showing.
I'm releasing all the stored oxygen that has been stored in the aluminum lattice. It's stored energy. That's what the, well.
It was a time of wonder and discovery.
Roger, Eagle, bend dock.
6 trips to the lunar surface revealed much about our closest celestial neighbor and changed forever the way we view our own planet. Today, NASA is looking towards returning to the moon, A permanent lunar base would complement space station freedom and provide a springboard for manned missions to Mars. And if researchers at NASA's Center for the Commercial Development of Space in Wisconsin are successful, the first lunar settlers will also be miners. Actually, this large automated vehicle would do most of the work, processing the moon's rocks and soil to remove a potentially valuable product, helium-3. Just 25 metric tons of this rare isotope, roughly the capacity of the shuttle cargo bay, could provide enough energy to generate all the electricity used in this country in an entire year. Helium-3 is produced by fusion reactions in the sun and carried through space by the solar wind. Earth's atmosphere shields us from the solar wind, but it has been depositing helium-3 on the moon for more than 1 billion years. Former Senator Jack Schmidt was part of the Apollo 17 mission, which marked our last, or as he likes to say, our most recent journey to the lunar surface.
We can't always use fossil fuels for the production of electricity. There are many environmental reasons why you don't want to do that. One of the most popular now, of course, is the addition of CO2 to the atmosphere. We don't need to panic, but we ought to be making those kinds of research and development plans that we have an alternative to coal and other fossil fuels in the not-too-distant future.
Studies indicate that the amount of radioactivity in a device like this generating energy from helium-3 will be 1/1,000,000th less than in nuclear systems used today. And no greenhouse gases, acid rain, or solid wastes will result. The proposed mining system will be equally kind to the lunar environment. Once helium-3 has been boiled off, the untainted rocks and soil return to the surface, leaving it essentially unblemished. The process should also produce a number of byproducts, including water, which will be of great value to a lunar colony. And according to Jerry Kolsinski, a professor at the University of Wisconsin and member of the NASA Commercial Development Team, current oil prices make helium-3 an even more attractive alternative.
At today's prices, helium-3 would be worth $4 billion a ton, which would make a shuttle load worth about $100 billion. And that's enough, I think, for any businessman to figure out a way to make a profit.
Helium-3 mining, using the moon's resources to meet future energy requirements on Earth.
Okay. Thank you very much for coming today, and I'm very happy to share what I have with you today, and I hope in the months to come that I get your support and we can make a difference. Thank you. Short break, and Calvin will be up next to show you his testosterone type device.